Welcome to this exercise video. We'll explore the basics of FlexSim with a warehouse modeling exercise. This exercise is perfect for beginners and will help you learn some key features of FlexSim step by step. The warehouse model we'll build includes 2 racks for storage, inbound and outbound conveyor systems for material movement, and a palletizer for preparing shipments. Before we start building, let's take a moment to understand the material flow diagram for this warehouse system. Let's get started. In the material flow, everything starts at the inbound shipment area. Items arrive at the inbound staging area. From there, the items move along the inbound conveyors to the rack staging area. The racking operation is managed using an automated storage and retrieval system, ASRS. Next, items go to the outbound staging area. Through the outbound conveyors, the materials are sent to the palletizer. After palletization, the materials are ready for the final outbound shipment area. This flow represents a simple warehouse process, and we'll replicate it in FlexSim. Start by creating a new model with the time unit set to minutes and the length unit set to meters. Before adding 3D objects, we'll import a 2D CAD layout of the warehouse. To do this, click the Background button and add a new model background. You can download the layout file using the link provided in the description. Once the CAD layout is ready, we'll begin building the model by dragging and dropping objects from the library. First, place a source object to represent the arrival of items at the inbound shipment area. Then, add a queue to represent the inbound buffer or staging area. Next, we'll set up the inbound and outbound conveyor systems. Go to the conveyor module in the library and select the normal roller conveyor. This type of conveyor is perfect for modeling item movement in the warehouse for this exercise. Once you drop the conveyor into the model, you can adjust its size by clicking and dragging the red arrow markers at its ends. The direction of flow will be indicated by yellow arrow markers. If you need to reverse the conveyor's direction, simply click the reversing button. Ensure that all conveyor directions are set correctly in your model. If you need to duplicate any 3D object, you can use the standard keyboard shortcuts, Ctrl+C to copy and Ctrl+V to paste. This saves time when adding similar objects to your model. Now, add 2 racks from the warehousing library. These racks will be used for storage operations. For material handling, add 2 ASRS vehicles. Modify the dimensions of the ASRS vehicles to match the rack structure. Simply click on the respective axis and drag to adjust the length, width, or height as needed. Place the first ASRS vehicle near rack 1 and the second near rack 2. To represent the rack staging area and the outbound staging area, use queue objects. These will temporarily hold items at different stages of the material flow, simulating staging operations. For the palletizing process, use a combiner object. Finally, add a sync object to represent the outbound shipment area. This is where items will exit the warehouse system, completing the simulation flow. Since we have added all the necessary objects to our model from the library, we can now connect and configure them. This involves establishing connections between the objects and setting their properties to ensure accurate simulation behavior. In the first source object, set the arrival style to inter-arrival time and specify a constant arrival time of 3 minutes. This means a new flow item will be created every 3 minutes. This model requires 2 types of flow items, as each rack is dedicated to one type. To represent these, we'll create a label on the flow items. Use the triggers feature to create labels, which can be set up in either the onCreation or onExit trigger of the source object. In the triggers data field, select the Set Label and Color option. Name the label type and assign it a value of either 1 or 2 using the discrete uniform distribution, dUniform 1, 2. This ensures each flow item is randomly assigned one of these 2 types. Once configured, connect the source object to the inbound buffer using an A connection and rename the queue object to inbound buffer for clarity. Next, connect the inbound buffer to the downstream conveyor system using another A connection. For the inbound conveyor system, we'll route flow items to the correct racks based on their type. To achieve this, use decision points, DPs, to define the routing logic. Drag decision points from the library into the model. Place 1 DP before the conveyor junction and 2 more near the segments leading to the racks. This setup will direct items to their destinations, Rack 1 for Type 1 items and Rack 2 for Type 2 items. Once the decision points are in place, configure an on-arrival trigger for the first DP. Choose Send Item by Case, which lets you route flow items based on their labels. Use the type label to determine routing, accessed with the code item.type. Add a case using the plus icon. If the type label equals 1, route the item to DP2, which leads to Rack 1. Use the sampler tool to select DP2. Similarly, if the type label equals 2, route the item to DP3, which leads to Rack 2. With this configuration, the conveyor system will automatically route items based on their type label, ensuring smooth sorting. Connect the conveyor segments to the rack staging areas using A connections. Then, connect each staging area to its respective rack. To enable material movement from the staging areas to the racks via the ASRS, open the Queues property window. Navigate to the output settings and enable the Use Transport option. Use the sampler icon to reference the appropriate ASRS vehicle. Repeat these steps for the second staging area to complete the setup. Each rack has 2 distinct faces, the pick face, highlighted in orange, for retrieving items, and the back face, shown in gray. Ensure the pick face is facing the ASRS in your simulation model. Connect the racks to the output staging areas using A connections and configure their properties. Configure the rack's properties. Begin with the slot assignment strategy, which is set to first slot with space by default. If specific slots need to be assigned to flow items, this can be done using the storage.item.assign slot property. However, assigning a specific slot through this property will override this slot assignment strategy. For simplicity in this model, use the random bay, level, and slot with space strategy to automatically assign slots. Next, adjust the flow properties of the rack. Enable the flow option to define the rack as a fixed resource, allowing it to receive items through its input ports and release them through its output ports. After enabling this feature, configure the following fields. Max content. This specifies the maximum number of items the rack can hold at any time. Minimum dwell time. This determines the minimum duration an item must stay in the rack before being released for further processing. For this model, set the dwell time to 30 minutes. In the output panel, enable the Use Transport option and assign the ASRS vehicles using the sampler. Repeat this configuration for Rack 2. Next, connect the outbound staging areas to the outbound conveyors. To implement the palletizer, use a combiner object. It requires two input ports, one for empty pallets and another for the items being palletized. For the pallet input, create a source object. In its properties, set the flow item class to pallet and configure the inter-arrival time to 0. This ensures an uninterrupted supply of pallets with no delays, based on the assumption of an infinite pallet supply. Connect this source to a queue, which will act as a buffer. Set the max content of the queue to 1, so it can hold only one pallet at a time. Then, link this queue to the palletizer. For the second input to the palletizer, connect another queue that is linked to the outbound conveyor. This queue represents the flow of items that will be palletized. Finally, connect the output of the palletizer to the last segment of the outbound conveyor, ensuring that the palletized items can flow downstream. In the palletizer's property window, set the combine mode to pack and configure the target quantity to 4. The target quantity defines the number of flow items required to complete one pallet. Additionally, set the processing time to 0.5 minutes to reflect the time needed to pack each pallet. We have completed the connections and property configuration for our model. Now, we can run the model. As the simulation runs, you can see that Type 1 items are directed to Rack 1, and Type 2 items go to Rack 2. The ASRS system is handling the material movement, and the palletizer is working as configured. To analyze the model's performance, we can create dashboards. Start by clicking the Dashboard button to open the dashboard window. First, let's create a bar chart to show the content levels. Drag and drop the content bar graph from the dashboard library. In the property window, attach the objects you want to monitor. You can add them one by one using the sampler icon, or all at once using the plus icon. Next, we'll create a graph to track throughput. For this, use the Output Dashboard template. Connect the last conveyor segments to the object field. Rename the title to Warehouse Throughput Pallets for clarity. We can also add a utilization graph. Drag and drop the state graph from the library and attach it to the ASRS machines. Finally, add a date and time display to show the simulation's time progress. Now, reset and run the model again. The dashboard will update in real time to display the model's statistics. Thank you for watching this tutorial. We hope it was helpful and easy to follow. Stay tuned for more videos, where we'll cover advanced features and share practical tips to improve your simulation skills. See you in the next video.